This is just my video tutorial on the AWS IoT application challenge that I discovered about a couple of days ago. So um, as a result of that, wanted to I've always wanted to use the AWS IoT Kinesis and other services, and just to understand how it works and how it can be applied to real world use cases and improve lives in general. So, um, so some of the projects that I've been working on include I've been working on about 4 or 5 projects using these technologies, and so one of the project is the smart home security and automation solution, uh, which is actually tied to insure for the users on one side and also for the insurance company on the other side. So for example, if there's a water leakage, so insurance company are always interested in things like this. So it's really nice to have a solution that not only help benefits the insurance companies but also the homeowners. And in addition to that, there is a voice control features using Alexa voice services and other artificial digital assistant services. so here, so here things like for smart home, we're talking about water leaks. Want to know the air quality, um, humidity, temperature, and then if somebody opening my door, closing on intruders, you know. So you want to know all these kind of things. So and then the second solution is the air quality monitoring in smart city using wireless sensors. So basically, uh, in this case, uh, the Raspberry Pi and also the AT&T uh, SIM card, IoT SIM card, and AvNet cellular shield are being used here, and this is the antenna. So this is basically going to be outside, and as a result, uh, where there is no Wi-Fi and all that, so it's necessary to have something in for this network layer that is wireless. And also this provides some kind of energy. This is a solar cell bank, and so in case there is no, because this is outside, so we need some kind of solar to power these devices. They are low energy consumption devices anyway, so this is really important. So and then there's a box here to protect the devices from the vagaries of weather like rain and things like that. Some of the components used here are the air quality sensor. So this is the air quality sensor. Okay. There is an environmental sensor here. Okay. And then this is the GPS module for logging location, latitude, and longitude. Then there are a couple of other devices being used like Arduino Uno, Arduino John, and so once all this data is collected, it is pushed to the AWS cloud. Now the third project is the remote fuel monitoring. So in remote fuel monitoring, um, actually involve, so I set up something similar to, for example, what you might think of in every fuel tanks, for example. So we want to monitor the level of the fuel tank, and I'm using the ultrasonic sensor to measure the height of the water, so as of the diesel tank fuel level, and then pushing that data from the sensor to the AWS cloud uh, through the Raspberry Pi gateway. Okay, so this is what it looks like. So it's not only relevant to fuel tank. This solution is also relevant to uh, diesel generators, heavy machineries, and diesel trucks or gas trucks. And last but not the least is the fleet monitoring solution, which helps to provide insights from data collected from electronic logging devices in cars, trucks, and track drive times. Want to know how many hours. So a fleet owner might be interested in knowing how many hours a particular driver has been, driving in a day. And not only that, government might wants to know according to regulations. So it's necessary to have this important data. So second one is location, temperature, engine temperature, speed, and you want to know the fuel level. And data is enriched with weather data and other data in the device and in the AWS cloud. So I will go straight ahead and do a quick demo. So here I have the Raspberry Pi, and it's connected to this small monitor, and once I run this script, it start publishing data to AWS IoT platform. So so it's, so okay, so I can get it from here. So this is the topic. So the device is publishing data to this topic, and I will subscribe to that topic. Of course, any client MQTT can subscribe to that topic, and then once that's is done, then data is being published to the topic. And now the second part is creating a rule. So a rule has been created. So what it does is, okay, whatever, so from here, anything that is published to this topic, any data that is IoT data that is published to this topic is, so there's an action will be triggered, and that data goes to the Amazon Kinesis Firehose delivery stream. So this is the Firehose stream. So it's published here, and then eventually the data will be pushed from that stream to the Amazon S3 buckets. So some of the data have been collected over time and stored here in the Amazon S3. I believe the latest one is probably this one. So these are some of the data, and yeah, and here quick insight can be done, and also analytics is being done using the Amazon Kinesis analytics, and also using the data warehouse, Amazon Redshift, valuable data, because a lot of the data coming from the devices in different locations are mainly noise. So by using Kinesis, all this data can be reduced. The IoT, AWS IoT is very nice for command and control, and and then the Kinesis is really good to, it ingests a lot of data, and then from there filtering is done to reduce the noise and get quality data into the data warehouse, the Amazon Redshift, and from there using creating a REST web service and also a custom UI user interface, and then so a customer can someone can do, have a quick insight. So in addition to that, there is this Amazon quick site service that also helps to get a better sense of what is really going on in the entire system, um, and also alerting and alerting and notification service enabled. In addition to that, data is also stored in DynamoDB, and part of it, part of this solution also use the AWS Lambda for transformation. Uh, so thanks for watching this video. Bye for now.